we'll start with this guy here, right? And the gist of this is we're going to use like similar triangles, right? So like you're going to see, and basically like this word problem could be like, so-and-so is standing here and then casts this, like they know how tall they are, and then they cast a shadow of 7 feet, right? And then they're standing next to the tree, right? And but the shadow on the ground, like for the tree, is 14 feet. So you're like, you can figure out from that how tall the tree is.
Yeah.
Right.
I already kind of looked at it.
Yeah. So it's like these are pretty straight. Like this is probably the easiest triangle question you're gonna see, but like a lot of the time people just forget to do this, right? So I don't know what your approach would be. I always like when I look at stuff like this, I always kind of go like, I identify the two sides of the triangle that match. You know what I mean? And then I'd also match this one up with this one, obviously. The shadows are shadows, and then like height with height, right? And then when you do that, you could say, like to actually solve this question, you can go 5 is equal to x, right? Because we're comparing them, right? But then you can write this as a fraction.
We gotta find x.
You find x. Like this is like, I don't know, week 1 or whatever, right? Yeah. So we can like, do you see how I set that up though?
Yeah, sure.
I just like, I find the two sides that are the same, I make them equal, and then the other two have to be equal, but we can write it as like a proportion, right? So like a fraction. Now all you have to do is just go like this.
Multiply all of it.
Yeah. So you don't actually have to use your, like for this question, you don't actually have to use a calculator. So what you're going to do is like this. Okay. So like your goal and like where you're going to like be stronger than everybody else is if you can like learn to do like manipulation all the time without actually using your calculator until the very, very last step. Because then like you think about, okay, now I'm going to sit here and I'm going to type, you're going to type all this stuff in, right? And it's going to take you time, right? So like what I'm going to show you is like, why can't we just like forget about typing in the calculator for a second? What if I divide both sides by 7? The 7's drop out. What's 14 divided by 7?
2.
2. So you can basically cancel that out, and x is equal to 2 times 5.
X equals 10.
You don't need a calculator. You know what I'm saying?
Yeah, you can
like think about how much time you would have saved to like, because then you would have gotten whatever 5 times 14 would be is, right? And then you would have had to like type it in again to divide by 7. You know what I'm saying? Whereas like I saw from the beginning that I could divide like 14 by 7. So I just isolated, right? Even if you got to this stage here and you couldn't really do anything, then yeah, type it in your calculator and you'll be done, right? But why wouldn't you try and do it the fastest way possible?
Exactly. Saves tons of time.
Yeah. Especially when you can do something like 14 divided by 7, right? So then you could say, okay, well then, therefore the tree okay. Now there is another way to do this, and maybe you have seen this before, I don't know. This is like one method to do it. The other way you can do is called what we call like and I'm just thinking about this now. This wouldn't, I just jumped through proportions because I like it. But you can find what's called the scale factor. Right? So the scale factor is like you can look at the side length, same idea. You're gonna find two side lengths that are the same in this case, or like equitable. You're gonna find 7 and 14. How many times do you have to multiply? Like what do you have to do to get from 7 to 14?
Multiply by 2.
Multiply by 2. So you can also do this here. So then x is equal to 10.
That's how I did it in my head.
Yeah, that's fine too. Sometimes like you're not gonna get nice scale factors. That's the only issue, right? So like, let's say this was 16 or something. Then what?
Then you gotta kind of
figure it out
like that.
Yeah. That's why I just like having one method that not that maybe having multiple methods, like they're like multiple tools in your tool belt, right? So it's good that you know those.
Yeah.
But I just find like if I can have one tool that kind of works all the time, like a universal one, then I don't need to worry about mixing up the other, like the different ones, right?
Yeah.
You know what I'm saying? Then I don't hit any questions that I'm like, I don't know what to do. You don't know which tool to use, you know what I mean?
Yeah.
So I just like that. Do you want to try this on?
Yep.
Yeah.
Oh. So it can't be much different than that one.
It's the exact same. It's the exact same with the exception of like this one is obviously right angle triangles, which doesn't matter. Okay. Now the definition for again, I'm pulling all this like I didn't write any of this down, right? But the definition for a similar triangle is that the angles match, but different side lengths. Okay, so you can see how like they've specified here using these that they're saying that this angle matches this one, and then this one matches this one,
which it looks like they do.
Yeah. So that's how they've, and then obviously I just guess they don't really put anything in the top one. So, but that checks the like similar. You're gonna ask yourself, are the triangles similar? This first step is like, do the angles kind of match? And then the second one is that they have different side lengths. If they were this like, if you had like same angles and side lengths, what would that be?
Equal triangle?
Yeah, so they call that, you said equal, not, congruent.
You're right, that's right.
You said equal, and I forgot what the word was.
I did too.
But there you go.
There's a different word for it.
Yeah. So you got similar and congruent triangles. That's basically all you'll do in that course, right? The more interesting ones, obviously, are going to be like the similar triangles because you can like have information on one and solve another. You know what I mean?
Yeah.
So why don't you try that one using that, and I can do it down here in this blank space. Okay. But you can choose to do it either way. So remember, you got your scale factor, so you can like find the two side lengths that are the same, and then find what the scale factor is, or you can just set up the ratio like what I did.
I was gonna just set up ratios just so I can get used to it.
Yeah. Okay, so just be actually that might you keep going. I don't know if that'll work or not. It would be a little bit different than what I would set up, but that's okay. It might work out anyway.
So I forgot how you set these ones up up here in your little template.
I would just do the cross multiplication, but don't worry about necessarily actually doing the math, right? So just do like 24x is equal to, and then put 16 in brackets and multiply that against 21.
And then what I want to do is try and put the word point first so I can cross the boat.
Yes.
So we're going to have x equals 16.
Okay. And before you do anything else, I'll show you a little trick here. Okay. So what you could do, and I just know this because I'm seeing it, right? And this is kind of cool. I've never done this before, like in showing anybody this. And again, I don't know if this is going to give us the right answer yet or not, just based on how you set up your ratio. I'll show you how I set up my ratio, and then we'd see if they get the same answer. So I'll write down what you have here first for a second. So it's 16 multiplied by 21 divided by 24. Okay, and what I'm going to try and show you here is like a way to do this without ever having to use your calculator. Okay, and this kind of gets back to yesterday. Remember how we had like x squareds? We could rewrite them as x's and x's.
Yeah.
So why can't we take like 16? Why can't I write 16 as 4 times 4? And then I could rewrite 24 as what?
4 times 6. And then, what is that? Oh, crosses at the 4.
You can get rid of one of the 4s. So now you can do 4 times 21, which might not help. It might not help you, right? I'm just like trying, like, let's just say you didn't have a calculator or something, right?
Yeah.
You're just trying to do this.
divided by 6. Well, 4 times 20, you could do mental math on that if you
Yeah.
just set it up like...
What's 4 divided by 6? How could you reduce that further?
2 divided by 3.
Yeah.
Or like 2 over 3.
So why can't you do this?
Over 3. That makes it a lot better. So that'd be 42 over 3. And then I think it's going to be...
You give me a decimal or something, right?
Yeah.
I think.
But if I can get to that, or like the answer of that...
But the nice thing about this... If I could get all my kids to do this all the time, that would be what I would prefer. You want to know why?
Is it?
Because if I were to go on to do something else with this answer, and I decided to round it, like whatever that is in the calculator, I don't know what it is, but let's just say we have 42 divided by 3. Oh, never mind, it goes in perfectly even.
Oh, okay, sweet.
Okay, so we got lucky. So, like, you could check that, but if what I'm saying is, like, okay. What I'm saying is, like, what if you got, like, 14.4? But it was actually 4.32165 or something. And you just decided to get rid of this.
You could just round it.
You could just round it, but then this is what we call rounding error. Right? So if I go to use this answer somewhere else, it's missing all of this stuff. So you're actually off by, like, depending on how exact you want it to be, right? Like, I'm sure if your dad was building, like, the house or something, right? He might not ever round that off. You know what I mean? Because if you round it there, and then let's say you multiply it against, like, another number that you've rounded, you have all this error, all this stuff here that you haven't used. You know what I mean? So your answer is going to be flawed.
Yeah.
So what I'm saying is, why wouldn't we leave our answer like this?
Because then there are 2 whole numbers that you can multiply, and it makes it easier.
You can just do this again. You can never stop doing it. You just multiply fractions. You know what I mean?
Because I know my teacher, she did say always try and keep it in a fraction. Don't ever put it into a decimal.
For that reason right there. We start eliminating numbers, that's a piece of that number, and you've just gotten rid of it. You know what I mean? So that now your answer is going to be missing that piece. Whereas with the fractions, it's always going to be there.
Even if you can go into a whole number, can you still...
Yeah, if like this would be the answer that I would want on a test. Knowing what the answer is. Now that I've typed it in the calculator, right?
Yeah.
Which makes sense, because 3 goes into 21 7 times. 7 times 2 would be 14.
Yeah. Let's see if I can get that answer here. Oh wait, is that? Wait, that's what you did.
I think that's that's
what you did. Yeah.
You know, as I'm looking at this is why I like this, because as I'm looking at this, we could have done 21 divided by 3. What is that?
7.
So it's 2 times 7. It's 14. So you don't need your calculator unless you have weird decimal things that are just nasty, like, you know what I mean? It's kind of like, I don't know, it's more satisfying to do it this way without a calculator, you know?
Yeah, it's
faster.
It's faster, so you don't have to sit there and punch it in. And then if you mess it up, you got to punch it in again. If I can try and do it, like reduce it so much that I can do the mental math on it, then it'll be good. There's one guy at my work, holy frig. He's a human calculator. Like we gave him like 96 times like 54 for a thing, and he pumped it out like faster than you would imagine. He'd be right.
That's crazy.
He's just a brainiac at math. Like, I don't get it.
I don't get that either. Some people are like, they just know the patterns, though, I guess.
Yeah, I don't know. He's just a human calculator.
Yeah, I don't get people like that. It's interesting though. Okay, let's. I'll show you how I would have set the question up, like how I would have said it earlier. Right? I would have gone. Remember what I said I found, and what you did is fine. So don't worry about this, because obviously I think we got the right answer. I would have found like the 2 side lengths that were the same.
Yeah.
Right? So I would have gone x is equal to 21, and then I would have put them each over 16 and 24. You know what I'm saying?
Yeah.
That's just the way I see it. But there's nothing wrong with the way you did it. See how it looks a little bit different than yours?
Yeah.
Like you had 16 over 24, is equal to x over 21.
Because I thought just if this was like the equal to that.
That's fine. I don't think it really matters too much. That's why I wasn't sure if your answer was going to come out fine, right? But
yeah,
it's all good. So either of those will do.
Alrighty.
That's why I like this one tool thing, right? You can just use the one tool and then use it in multiple scenarios, you know?
It works. I'm just going to write this down so I don't forget it.
Okay.
How did we do that again?
What did you say? You could reduce it either way. The 6 going to 21?
No, it goes, we could reduce that.
The 4 over 6, right? We said was what?
2 over 3.
Yeah. Right? And then we said, okay, well, what's 21 divided by 3?
7.
Yeah. So you're going to have 2 times 7, right?
2 times 7 equals 14.
There you go. Now you could write your missing side length, therefore your statement, right? There you go. Easy. Okay?
Alright.
Now, before we do this question here, I want to show you something. I didn't really include it anywhere else yet, so I want to show it to you here before we actually do this question. So obviously you would have remembered like the Pythagorean Theorem, right?
I always forget that.
Okay.
What's the formula?
But you remember doing it though, right?
Yeah.
So basically, like when we label a triangle, this is how we label triangles, right? Yeah, this is the next one. So we have like A, B, and C, right? We just have like corners, right? In capital letters. And then the way I always do the side lengths is opposite. Like if I were to like, that wasn't great. So capital A, this side must be little a.
Yeah, and then, yeah.
Right? And then this will be little b, and then this is little c. Okay? Does that make sense? That's how I do it all the time. I don't know, it just keeps me straight in my head. Like, so you have angles, which are going to be your capitals, right? So this question here, like we could replace alpha with capital A, angle A, right? Because it's just going to be this. That's what the question's asking us. But what I want to do first, just as review, is I want you to find the side length, right? So with the side length, anytime we're solving, and here's the catch with this, to solve for the only time you can use what I'm about to show you is if you see a 90 degree here. So we're going to use Pythagorean Theorem. Okay, and you can use Pythagorean Theorem for all side lengths in a right angle triangle. Okay, so Pythagorean Theorem. Oh boy, that's one, right? I think so. Close enough, whatever. Okay, so we gotta go, here's how Pythagorean Theorem works, right? It's a squared plus b squared is equal to c squared.
Oh, I've done this, yeah.
Yeah?
Yeah.
Okay, so you can use this, like, and I'll show you an example later. I think there's probably a question at the very back of this, where we're gonna combine this with like surface area and volume, right? And like this pops up all the time. Like you can use this to check whether or not you're square. Like if you were building like, if you were like doing pouring a pad or something, you needed like a square or like it's just a right angle corner. You could use this to like make sure that you were square, right? This is useful, like real life stuff.
Yeah.
So what you're gonna do is you're just gonna like, A was 8, C is 15. and I didn't really label this too well. So that's the other thing here. So the big side length always goes on the hypotenuse. I didn't label my triangle too well.
So would that normally be C then?
Yeah, here, I'll change it just because what we're doing is...
Okay.
Like this, yeah, it's always going to just write a squared plus b squared equals c squared, and then we'll label the triangle. Okay, C is always going to be your hypotenuse. That's my bad.
All right.
It doesn't really matter because they're just side lengths, right? But we'll keep it straight. And then the hypotenuse is obviously the big side, right?
Yeah.
Okay. So it's always the big side. It's the two small ones. The way it works is like the sum of the two squares is equal to the hypotenuse squared. Okay.
So we just plug it in.
You just plug it in now. So you're going to go 8 squared plus 15 squared is equal to c squared. Okay. And then this is probably where you're going to need your calculator because I don't necessarily know what 15 times 15 is. Right. But we know 8 times 8 is 64. It might be 225. Let's check. 225. This is 225 is equal to c squared, and then we're going to do the addition on that. It's 289. Now, what do you do at this point?
You square root it.
Okay, good. Yeah. So the way this works, this is like a normal equation, right? So if you had like, we're solving for x or we're solving for the variable, the opposite of squaring something is square rooting. So you're technically square rooting both sides, right?
But so then that'll take that.
That takes rid of the 2, right? Because it's like the opposite. It's like if it was multiplied on the right side, then you would just divide and would get rid of it.
So nobody's ever explained why that 2 doesn't. I just have always taken the 2 out. I've never known why that happens though. Because
that's like an exponent thing. It's like, and I don't. You'll do that in the 3C course, but just know that like if you have something squared and you square root it, they cancel.
Because it's the opposite.
It's the opposite.
It's like multiplication and division. Cancel each other.
Yeah. There you go.
Alrighty. So then what's 289 square root of 289? So then we can just rearrange that C equals 17.
Mm-hmm.
Perfect.
Okay. Now, I'm going to show you something else now. So we're actually going to answer this question. So that's like Pythagorean Theorem. So that's like for solving for side lengths. Okay, you can use that for side lengths.
I should probably write this down.
Okay, so you have like you have 2 different things that you can use. Okay. So that Pythagorean Theorem is only for side lengths. You can't use it for anything else. Okay, it's not like you can use it to solve for angles because it doesn't make sense, right? Like you only have places to plug in side lengths, so you can only solve for side lengths. Okay. The next one I'm going to show you. Okay, that was like an extension of this question. Do you remember?
SOH CAH TOA?
Yeah, have you ever seen this?
Yeah, I forgot how to do it. What? I think I did okay with it. This is trig, right?
This is trig. Yeah. Well, Pythagorean Theorem is trig too. Anything with triangles is going to be trigonometry.
Is it?
Yeah, anything triangle.
Okay.
So this is also trig. Okay, this would also be kind of like trig, just kind of proportions. Nothing too fancy, right?
Yeah.
So the way this works, okay, this is like an acronym. Okay, and it's you got your table. Let me get your table there. Okay, the table is like you keep this because this is, I don't know, this is like a no-brainer. Okay, so the way this works, okay, your job here. Okay, I gotta erase some of this stuff here. Let's get messy. So what I want you to do here, okay, we have this angle, okay. Here's one. We'll start with the thing that never changes, okay. So you have this 90-degree thing in the corner. Opposite of it is, what did we say this was?
17. Oh, that's
17.
C.
C. But what else do we call it?
The hypotenuse.
The hypotenuse. Always. Always, always, always. And what is the hypotenuse?
The longest side. On the
longest
triangle.
side. Where do you notice it's opposite of?
The biggest angle.
Trying to give you a rule to write down here without confusing. So let's say hypotenuse, we'll put in brackets biggest side, goes with biggest angle.
Yeah. No, I get that.
Okay. And that's 90 degrees. Okay. And it's always that, because you can't use SOH CAH TOA if there's no 90 degree. Okay, so that's like a rule. Like, this is just given. You see this, you're like, okay, I know what H is in both these two. Okay, just right off the bat. Okay, so next thing now, the question's going to ask you about one of these two angles, the remaining two. Okay, in this particular question, it's decided to ask us about alpha. Okay, so I'm going to stand at alpha, and I'm going to look across, and I'm going to label this. If I'm looking across, what do you think I'm going to label it?
A. Oh, I forget all the, like, is that the optimal value?
So here, I'll write it out here. Here, let me rewrite SOH CAH TOA here. So you're gonna have, okay, so with S is for sine. O
Opposite, yeah.
Okay, you see that? So if I'm standing at alpha at this angle, and I decide to look across from me, then this is opposite. Okay. If this question asked me about this angle, then I'd be standing here instead, then this would be opposite. Does that make sense?
Yeah.
Okay, but that's not what it's asking me to do this time. So you're standing at A and you're looking across, there's opposite. Okay. Now the last one that you have to label is, if we go back to, we'll do like CAH. Okay, so this is cosine. And what do you think A stands for?
Adjacent?
Adjacent.
Yeah. And that's hypotenuse again?
It's hypotenuse again, yeah. Okay, so that's, you got O, H, and A, and then you've got sine, cos, and tan, okay? And all these things they're doing is they're just ratios, okay? So your only job here, okay, I'm going to get rid of these. You okay with this?
Yeah.
You can watch it after, and it'll all be there. Your only job with this is to write a ratio using the side lengths that you have, okay? So pretend we didn't do Pythagorean Theorem and didn't find 17. We just decided to start this question, okay? The only two side lengths that I had in this question was 8 and 15. Okay, and what were they? 8 is to the opposite, and 15 was adjacent. Do you agree?
Yeah.
Okay. So if those are the two things that I have adjacent, and I have opposite. I've written this wrong. Which trigonometric ratio does that sound like?
I don't really, I need a refresher.
Okay.
Well,
So your job is to like remember what you just said to me. We know opposite and we know adjacent.
What is
So
it, TOA?
It's TOA, right? Because
it's...
I can't use sine and I can't use cosine because they both require no h, which means you're forced here.
Because it's the signs are the O and the A.
The O and the A that you know. Okay, so the way this works is you're just gonna go like this. Okay, well, I'm gonna take the tan. I'm gonna clear some of this. Okay, you're gonna go tangent of the angle because that's what I want to know. Tan of alpha is equal to opposite over adjacent. It's always like you read these things, it's always the first one over the second one. Does that make sense? So for sine,
because it's like you're reading. You gotta go
O
over the A.
Yeah, O over the A. So that's what you're gonna do. O over A. Okay. What is O from your diagram?
8 over 15.
Okay. Type that into your calculator, and then I'll show you how to use the table. Right. So we'll type 8 over 15.
0.3.
Okay. Okay. So here's what's great about the table. Okay. Normally when we got to this stage, we'd have to like. Do you remember having to do like the tan inverse?
I don't remember that. No.
Okay. So I'll show it to you just because I don't know what your teacher's going to show you. See that tan inverse?
Yeah.
That's like doing the opposite of this. So if I were to divide both sides by tan, right, then I would have tan inverse over here for 0.533. If I did that, then I should get this in. So if I actually hit tangent inverse, there's my angle. Okay. Which is like, I don't really, like a lot of kids break down here and they're like, I don't understand what's going on, right? Because, and then like for me to like switch it up on you, like kids just get lost, okay? The reason why I don't like that is for exactly that reason. And that's traditionally, like that's how I got taught, and I never seen this table until I started teaching, okay? Which is kind of unfortunate because it's honestly the better way to do it, which is why I'm saying to hold on to it, okay? Because your teacher may or may not teach it this way. I don't know. Okay. So we get to this stage. Forget everything I just said there. I just did it just for formality. Okay. Your job. So if we go down to, I didn't put it in here. Okay. Your job is to go to the trig table. Okay. And find the column that's O over A. Because it's tangent. That's what I'm doing. Okay. So find the column that's like opposite over adjacent on your trig table. And there's two different rows here. Okay, so you're going to just like, this is a continuation. It should be like slotted down here. Just keep going.
Yeah, I was looking at it. It kind of goes, yeah.
Yeah, okay, so you're going to find which one's O over A, like the tangent column.
Well, they're both.
Yeah, there's two of them, right? So here's your job. Okay, so that's good. You identified that. Your job is to go in that column, okay, and find me this decimal. When you find it, stop. Okay, that's close enough. Now, it might not be exact. Okay.
0.537.
Okay, now, wherever it is, 0.5 whatever, this?
Yeah.
Read across.
Oh, yo, that's cool. That's so much easier.
There's no thinking.
No, you just look at it and then boom, there it is. Wow. Wow, this is like my own little cheat sheet.
But it's not really, right? You still have to know how to use it.
Yeah, like,
you know what I mean?
So, what are these numbers for then? These ones?
They're for, we'll do a different one. We'll do a different one in a sec, okay? I'll do it again in a second, okay? So that, what did we said alpha was, and so let's for a sec, we said you found two different 0.533s, right? Or is it just one?
Just one.
Okay, so just say it's that one. Okay, so it's 28 degrees. Done. Okay. Now, what if for a second, pretend that this question didn't have the opposite anymore.
So you need to find the hypotenuse.
We found the hypotenuse, okay? But
See.
pretend that we didn't do all of this work here, okay? So you're given the fact that it's 17 in the question. Your job now is to answer the same question. I want you to tell me what alpha is using this piece of information with this one.
So we got to find something with the A and H in it.
Yeah.
It should be.
What is that?
Cosine.
Cosine. So I'm going to do cosine alpha is equal to A over H, right?
Which is going to be 15 over 17. Also, I have a question. I know my teacher had a little bit of a different sign than that. It kind of looked like a circle with a little...
So these are all Greek letters. Alpha, beta, there's gamma like this. That might be gamma. But then the two that you've probably seen are like theta and phi.
Theta is the one I mean.
This is just they're all Greek letters. They're interchangeable.
Okay.
Okay. They're just symbols. It's like a X, right? It's just they typically use these guys for angles and stuff instead of, and they keep the variables like the English letters for actual variable. Okay. All right. So that's good. So here's where things get interesting because you asked the question, when do we use the other two columns? So what I want you to do now, we need to figure out what 15 divided by 17 is, right? As a decimal. Okay, so 0.88. 8823, you could even say. Okay. So now you're like, okay, well, you got to go, now I want you to go to the table. But this time, what column are you going to use?
This one.
Because it's A over H. Okay, so go find that decimal for me.
Close enough. 0.8829.
That's fine. What's the
28? Angle? So it's still 28.
So it doesn't matter. It doesn't matter which trig ratio you're using.
It's still going to come out the same.
This angle has to be 28 degrees. Because of the ratios. You've got 17, right? And you've got... does that make sense?
Oh, yeah, that does.
Okay, so why don't... I'm going to throw a wrench at you now, okay? Right. You're going to do the exact same thing, but we're just going to switch it up a tiny bit. Okay, so what's different about this question relative to the last one?
It has one of the angles.
Okay.
You already know two of them, and it's got only one side.
Okay, so in this question, it wants us to solve for the side length instead. The process doesn't change. Okay. Let's just we're standing at this one. I want you to label the triangle. So I'm going to stand here and look across. What is this?
It's going to be, so the 90 is going to be C.
Yeah, or we could label this hypotenuse, right? It's always opposite the 90.
So it's going to be A, and then the bottom is going to be B.
Yeah, okay. So let's move away from the ABC just because...
Oh, okay. All right.
Let's do H because this is what I want to use. I want to use SOH CAH TOA.
That's right. Okay.
So let's label them like that, okay?
So that'll be opposite. And
the 15?
Yeah. And then X will be adjacent.
Good. So another word for adjacent is beside. I don't know if you knew that or not.
Beside?
Yeah. So you're like standing here and then adjacent is going to be beside you.
Yeah.
Okay, that's where that comes from.
All right.
Okay. So now we have to figure out what are the... Okay. The question is like, I know some stuff and I don't know some others, but they're all going to fall in like one equation. Okay.
Mm-hmm.
So let's identify, again this time, I'm not going to use hypotenuse, right, because there's nothing there. What I am going to use is the two other sides, right, opposite and adjacent. I'm not going to worry about the fact that I don't know this yet, okay? I'm just trying to pick which of these three I'm going to use, sine, cos, or tan. Okay. I literally have nothing with hypotenuse, so I can't use it. Okay. So your goal is we're going to rewrite this, just a general statement, like this guy here. Okay. We're just going to rewrite a general statement. But I have opposite and I have adjacent, pretending. So I'm going to write tan of, we'll use theta this time for you, okay, is equal to opposite over adjacent. Does that make sense? TOA. Okay. So now you fill in the information. Let's start over here with these guys. Okay, tell me what goes where.
The 15 is for opposite.
Yeah.
And the X is for the A.
Okay. Now, what goes here?
60 degrees.
So it's a tan of 60. Okay. Now we're in business. I've got something here. Okay.
I forgot how to calculate that.
The tan of 60. Traditionally, you'd just go to your calculator. You'd go like this, 60, and then you'd hit tangent. Okay, that would be your answer. But don't do that. What I want you to do, go find 60 degrees on your table. Read across to the tangent column.
What's that?
Good. So what's the number on your table?
1.7321.
Now I want you to solve for x.
We can rearrange it.
How are we going to rearrange? Just going to cross multiply, right?
Yeah. So then you do 1.7 through that 1.7x. Just 15.
So x is equal to 15 divided by
1.7321. And then whatever that's going to be, that'll be your angle. Or that'll be your x. And then you can find your angle from there.
But we know the angle.
The top one?
Oh, we can do that too if you want.
You can also, another thing, like I think all the angles inside of a triangle have to equal to 180.
That's how we're going to find it.
So you just,
That's good. 1.732.
Because then once we find the x, we can find the hypotenuse, and we can already find the other angle in there, just be knowing they're 90 degree and 60. Which is going to be 30 degrees, I'm pretty sure.
Yeah.
Because I don't know, can we use that for the hypotenuse as well?
Yeah. Yeah. So like, let's say like the way I would word this question, you can try this one next. But if I wanted you to like, if I gave you this triangle and I said solve, just the word solve, I'd want you to find this, I'd want you to find this, and I'd want you to find this. You'd solve for three things. Okay? If it asks you for one specific thing, in this instance it asked you for 8.66, then I just want that. You don't have to do the rest of that. But everything you're saying is right. The sum of all three angles in a triangle have to add to 180. So you can go 180 minus 90 minus 60. 180 minus 90 is going to be 90, minus 60 is going to equal 30. So you're right. Okay? And then to solve for the hypotenuse, you're going to use and solve for c squared. Then you're done. That makes sense?
Oh, yeah.
Okay, so the table is like key.
I'm keeping this.
Right? It's like there's no thinking involved. If you're given a degree, then you get the decimal. If you're given the decimal, you get the degree. Whereas with the calculator, you got to go, I can't remember if I'm hitting tan or tan inverse, or like sine inverse or sine. You know what I mean? It's hard to keep that straight. So like you just use the table, and eventually you will learn to use your calculator. But the table is like.
Will I be allowed to take this into my exam?
Yeah, it's just that whether or not that was on our exam, so we gave all our kids that. It's just whether or not your teacher lets you do that.
I'll talk to whoever I have. So I've got to show.
It's not a bad it's another tool, another way to do things, right? You're gonna get the same answers.
Alright. That's cool. I like that.
Okay, try it. Good. Try it. You try the last one, and then we'll see how we do here.
I mean, I like how, like, just to get myself into it, I like having the, what we did before, just so I can get a template.
You leave it up here?
Where numbers go, yeah.
Okay.
So
again, like, when you label this, label it HYP, like, opposite adjacent hypotenuse. That'll be more useful for you.
I guess I could use this template.
So you chose tan because what?
Because I have a opposite and adjacent.
Good. So now just write it out a general statement, like your tan theta is opposite over adjacent, right? And then you can fill in the information now, based on what you have.
I need to get better at those phases.
I always write a circle and then come back after with the stick. Like, this is okay to do too.
Oh, that is too?
Yeah.
Okay. So then it's over 20.
And what's theta in this question?
68 degrees.
Mm-hmm.
So then we can just plug that in right now. 68 equals x over 20. So oh, I know what I could do.
So for this is actually easier than the last question, for the reason that, like, you're going to find out in a second. The number is on the bottom of the fraction. So all you have to do is multiply both sides by 20, and you have x by itself, right?
Because you're dividing it by 20.
Yeah, so if you multiply both sides by 20, you have x by itself.
So you just do top times 20 and bottom times 20? Or how do you...
You keep going. See, I may have confused you. You continue. Right where you were going to write out there.
Yeah.
What you were doing, I think, is perfectly fine. Don't let me confuse you.
You gotta figure out what that is. I just get out my calculator.
You gotta write a step. Write a step, and then that way you don't forget it. So whatever you're about to type in your calculator, write that down. That way you don't forget. Nah. I'll type that in.
I don't know why I put the brackets there.
Because you were thinking to multiply against 1, right?
Yeah.
But that's okay. There you go.
And then, so I shouldn't round that.
Nope, that's it.
So that's, what did you solve for x? So that's 49.
Mm-hmm.
The x.
Why don't you solve for the whole triangle now? Like, you can
Okay.
do this question because I've shown you everything.
So I can just do 60, 22. So this is 22 degrees. That's 42. Now we can do
Okay, so then you don't have to just turn your phone sideways and then just hit second function yet. You don't have to retype that. You got a lock?
No, it's not on that. Oh my god, why is it not working? Here, hold on. Maybe it's because my phone isn't unlocked. Okay, let's try this again. Oh, that was right. I was just doing
it was locked, yeah?
Yeah. So just hit second function, which is where?
Second function, and then be where the x squared normally is, right?
Oh, mine might be a little different than yours.
This is a little two inside the hook. It's like third row down, second in from the left.
Mine aren't changing all that much. It's just.
Oh, we might not have to hit second function. That's my bad. Oh, yeah, it's just this guy here.
Oh, I thought maybe that was
the one with the square root. The square is the 2, and then the root. Square root.
I was looking at that. When I saw the 3, I thought that's something you...
That would be the cubed root.
The cube, yeah.
Yeah.
So that'd be 53. Wow, do I have to write all that in?
No. So generally speaking,
just round it?
There's this thing called like significant figures, which they don't really talk about until you get into like, I don't know, college or whatever, right? And then sig figs worker, like, you can only be as precise as the numbers that they give you in the question. You know what I mean? So by looking, I don't see any decimals in the numbers that they give you in the question. You know what I mean? So like as you went overboard with your rounding there, like even the 49.502, like you can't be any more precise than what they give you in the question. That makes sense, right? Because they're like, I don't know, they just...
So you kind of have to round it to a whole number?
Yeah, just round it to a whole number, basically.
Okay.
Right? Because that's all they've given you in the question.
Because if you go with 3, you have to up it to 4, which 4, so
and
just stay 53.
You're getting all these decimals too after the fact because of what you carried here. It might have been not as bad. Right? So there you go. That would be like if I said solve this triangle. You tell me all 3 angles, all 3 side lengths. So there's 6 pieces of information on your page, right?
Yeah.
So there you go.
So I just found all of them.
Yeah.
And I had to look a little bit at the template at the start, but
that's the hardest part, though. Like, most of the time kids don't have an issue with the a squared plus b squared equals c squared. It's this thing they have issues with. But you're doing more thinking, like, I think when we did this with our kids in 2P, the reason why these are highlighted is because we told them that those were there was no thinking going on. You know what I mean? You're already doing more thinking. Like, we told them they had to use tangent. That's why this is highlighted. You know what I mean? Whereas you were deciphering between which of the 3 to actually use. So you're already you're ahead of what you're supposed to be at. You know what I mean? Yeah. So you and then I showed you you can use tangent or sine or cosine relative to tangent, and you get the same answer, right? So you're ahead of where you're supposed to be for that. Anyway,
that's good.
Okay, the next thing I had here is, do you have there's a whole bunch of these, which you could do. It's in. You already have this, so it's in your. I think it's in your practice example, but that way you can knock some of that off. But I wanted to do a word problem.
Oh,
okay, and again, it's no different than what I showed you before, right? With the linear right there.
Should I write it in here?
Yeah, that's fine. You're eventually, like, I gave you that so you can, like, you can go back now after, like, today's session and, like, you can work at it on your own pace, but then if you go to the YouTube channel too, like, I've done this whole thing. So if you're stuck on a question, you can watch it. You know what I mean? So what I want you to do with this one is you'll find this is a really easy question after you get the diagram drawn. Okay. So why don't you, we'll read it. Okay, so the flagpole casts a shadow of 14.5 meters long. Okay, why don't we like draw a flagpole? Okay, and then draw its shadow on the ground. Okay, now the flagpole was how tall? Oh, we maybe misdrew. So here's the thing: when you draw these diagrams, I don't know, 14. Make sure. I don't know how long the shadow is going to be, but just make sure that like when you draw these things, they're like proportionally kind of make sense. So this is going to be 14.5, right? That's the flagpole. You could even draw like a flag there, right? And then at the same time that a person 1.8 meters tall stands and casts a shadow of, how tall is the shadow? Or how long the shadow is from the person?
2.5 meters long.
Yeah. Okay. Find the height of the flagpole. Sorry, we labeled this wrong. 14.5 wasn't there. 14.5 is on the ground.
So it's 90.
Yeah, they're both 90s.
Yeah.
So typically, like, yeah.
So we're trying to find the height of it, so we'll just label it X.
Yeah, good.
So then after we're going to find the hypotenuse of that after? Or no, we're just trying to...
What does that represent? Just out of curiosity.
That?
Yeah. What would this represent from here to here? In real life.
Not the distance between them. Where is it the distance?
It'd be like the how far it actually is for me to look from here to the top of the tree or the top of the flagpole, right? Okay. It'd be like the actual line of sight is this long. Okay, so like, do you hunt?
I fish.
Okay, the hunting, like I say hunting because like maybe you're in like maybe you're standing in like a blind.
Like a tree or something?
Yeah. But like you're up here, you're in the blind, right? But the deer is down here or something. Right? So like the deer is actually only this far away from you, right? But your bullet to shoot the gun, like shoot the deer, actually has to travel this far.
Which is longer.
It's longer.
Yeah.
That's what that means.
That
in a different scenario, right? That makes sense?
Yeah. So
like for our flagpole, it really doesn't mean anything, right? Because it's like it's just the line of sight from there to there. One that might resonate more with you would be this. What about, and like they make stuff to do this. Let's say I'm hitting a golf ball to like an elevated green, right? So like the green's up here with the flag, and I'm down here. I'm gonna hit it, right? The whole the yardage sign says it plays 180. Are you gonna hit it 180?
No, you're probably gonna have to hit it like 200.
Yeah, maybe over. Depending on what.
How far the pin is from the ground and how like the distance you have
to
go. Because it's gonna be longer from there to there than it is from like 180 yards to the green.
So depending on the angle or how steep this is, right? That's gonna change this, right? Yeah. That's just based on our conversation today with slope, or not slope. So hypotenuse, right? So we have a bigger angle here, right? Then this is going to be larger. That makes sense?
Yeah.
So they call that the slope in golf terms, right? Because they sell. Did you see my Bushnell down there? You used a laser finder? You never used one? I'll show you it after. The way it works is like it's a laser. It hits the pin and tells you it's 180. But they make them based on like how you're holding it. It'll tell you what this yardage is.
That's cool.
So
I've seen people use them before at my course.
That's what's called the slope feature. Okay, so like based on the tilt of the rangefinder, it'll tell you how far you actually have to hit it. Mine just does this. Okay, it just shoots it straight on, so it won't actually do the calculation for you. But that's what it's doing. It's doing a little bit of trig to tell you what this hypotenuse is.
That's cool.
Okay, it's a little more money, but it's a very straightforward calculation that it does. Right. So let's not that involves anything. Like, why don't you solve that for me? Okay, and then tell me how tall the flagpole is.
All right. So I'm gonna label these.
Okay, do you need to do that? You can. Is that your fastest way?
Probably not.
Well, it's probably not because I've said that now, right?
Yeah, I've been wondering why now. Well, I mean, I'm always going to know this side's opposite. Like, any of the left or right side's going to be opposite.
It could switch, though, depending on what I say, right? So if I want, like, if I ask you about this angle here, now this is opposite. You know what I'm saying? So that's where they switch. And then this would be adjacent, right? If I was asking about this, then yes, it would be opposite. But it can switch depending on what I ask you on, right? So what I'm saying is, though, what you're about to do is probably the slower of the methods that I've shown you today, right? What do you have? I have two side lengths that are comparable. And another two.
Yeah, because I could write these out in a way that I'll get an answer, like we can like reduce it down so I don't even have to use my calculator. Because we don't know that yet, so I can't like go off that. So I have to go 14 over 2.5.
Yeah. What
or
you
the other
would,
way around.
I don't know if you would actually get an answer the way you're trying to do it. You'd be chasing your tail because you'd be like, I don't have this, and you try to calculate this. It just wouldn't get you anywhere. You know what I mean? You need an angle to do what you're doing.
90?
Yeah, that's like a trivial one. That's not really a... Yeah, that's not really a real one. I mean, it might work. The sine of 90 is just 1, though. Sine of 90 is 1. Cosine of 90 is 0. It's not really useful. It's better for you to use the similar triangles. This sets it up using a similar triangle question, right? So you're going to use this one, this method that we talked about.
Because we have all three of those, it's all we need.
You've got 3, you just need to find the 4th.
And that's what the x comes into play. That's what that x is.
Yeah.
Okay, so...
And remember, you had your own way for doing this, right? And it worked.
Yeah.
So you don't have to follow mine. What's the next step?
I want to put it all over something that I can't... I don't know what that would be.
Well, yeah, you want to put it all over something, but the way to do that, like, your goal is, remember, to get x by itself. So how are you going to get x by itself? That's what you're trying to solve for, right?
Mm-hmm.
So how are you going to get x by itself?
Gotta divide everything by 2.5. Get x right here, that cancels those out.
How you do the math on that? You just type that in. That'd be an example, right? Where like
I can't really do that.
no,
Yeah.
that's a little uglier.
So 1.8 times 14.5 divided by 2.5. Yeah. I'll do that again. I don't know. I don't trust that. 1.8. I guess it was okay.
There you go. And it's what? But don't forget your units. What was the question saying? There you go. And then you could write a therefore statement. That's it.
Therefore,